Hello bachcho, let's read the question. Let fx is equals to mod of x minus 1 plus signum of sin x if L and M denote the number of points on x in the interval open at -1 to closed at pi, where fx is discontinuous and non-differentiable respectively. Then find L plus M. Solution शुरू करने से पहले let's note down the key concepts for this problem. So first is the definition for differentiability of a function at a point. So here a function f is said to be differentiable at a point say x equals a if limit x tends to a, fx minus fa divided by x minus a exists, and if so, then f dash at a is equals to the limiting value. So here we have limit x tends to a, fx minus fa divided by x minus a. The second key concept is the function signum of x is defined as -1 for values of x less than 0, 0 for x equal to 0, and 1 for x greater than 0. The third key concept is the converse of the statement differentiability implies continuity, and that is if fx is discontinuous at a point x equals a, then fx is not differentiable at that point, that is x equals a. With these three concepts, let's now start our solution. In the question, we have been given the function fx is equal to modulus of x minus 1 plus signum of sin x. Now, to get the signum of sin x, let's first look at the graph of function sin x. So let's draw a rough sketch of sin x over the concerned interval. So suppose this is x-axis, here we have y-axis. Our concerned interval is -1 to pi. So here somewhere is -1 and here somewhere is minus pi by 2, and pi will be somewhere around here. Now at -1 the function -1 is not in our domain, so the function is not defined here. We don't need to define the function here. So sin x function will look like, so at minus pi by 2 the function takes minimum -1, so this will go, so here we have a hole at -1 and the function goes 0, and at pi by 2 we have maximum value 1, so this the function goes like this, and at pi, the pi is in our domain, so we have a solid point here. Now such is the graph of function sin x over the concerned interval, that is -1 to pi. Now therefore we can write signum of sin x equal to, so to the left of 0, that is in the negative side of 0, the functional value is less than 0, and so therefore signum of sin x will be -1. At 0, functional value sin x is 0, so therefore signum is 0. Now for x greater than 0 and less than pi, the functional value of sin x is greater than 0, and that is therefore signum will give us +1, and at pi sin x is 0, and so therefore signum of sin x is 0. Now, with the help of signum of sin x, let's try to simplify fx and write it in piecewise fashion. So here we have function fx will be equal to, at x equals to pi, so the functional value will be pi minus 1. When x lies between 1 and pi, so the input x minus 1 will be greater than 0. So therefore the functional value will be x minus 1 plus 1, that is x. X lying between 0 and 1. So here the function will be 2 minus x. At 0, the functional value will be 1, and in the interval minus 1 to 0, the functional value is minus x. Now with these piecewise definitions of fx, let's check continuity and differentiability at various points. If we observe here, we have breaks at pi, 1, 0, and wherever the function has no break, that is in the interval 1 to pi, 0 to 1 or minus 1 to 0, the functions defined are continuous, also differentiable as well. So therefore we need to check continuity and differentiability at these breakpoints. So firstly, let's check continuity and differentiability at x equals pi. At x equals pi. At x equals pi, let's check continuity. So limit x tends to pi minus of fx will be equal to limit x tends to pi minus of. So to the left of pi, the function defined is x, and so therefore the limiting value here is pi, which is not equal to pi minus 1, which is the value of the function at pi, and so therefore function fx is discontinuous at x equals pi, and therefore not differentiable. Further, let's check at x equals, the next breakpoint here is 1. So let's check continuity for x equals 1. So limit x tends to 1 minus of fx will be equal to the left of 1, the function defined is 2 minus x, and that is, so here we have limit x tends to 1 minus of fx, that is 2 minus x. So the limiting value here is 1, and f of 1 is equal to 1. Also limit x tends to 1 plus of fx. To the right of 1, the function defined is x, and the limiting value is 1. So therefore f is continuous at x equals 1. But if function is continuous, we cannot talk about differentiability direct. We need to check the limit. So let's check that limit. So here we have limit x tends to 1 minus of fx minus f of 1 divided by x minus 1 equals, to the left of 1, the function defined is 2 minus x. So here we have limit x tends to 1 minus of 2 minus x minus f of 1 is 1 divided by x minus 1. So here the limit turns out to be 2 minus 1, that is 1 minus x. 1 minus x divided by x minus 1 is minus 1. Now let's check the limit, right hand limit. So limit x tends to 1 plus of fx minus f1 divided by x minus 1. To the right of 1, the function defined is x, and so here we have x minus 1 divided by x minus 1 equal to 1. Now since, so here we have, therefore we have limit x tends to 1 minus of fx minus f of 1 divided by x minus 1 not equal to limit x tends to 1 plus of fx minus f of 1 divided by x minus 1. Therefore f is not differentiable at x equals 1. Now further, let's move on to the next breakpoint, and that is at x equals 0. Now at x equals to 0, let's check continuity first. So limit x tends to 0 minus of fx is to the left of 0, the function defined is minus x, and that is limit x tends to 0 minus of minus x equals to 0. Now let's check f of 0. F of 0 is 1, and so therefore f is discontinuous at x equals 0, hence not differentiable. At x equals 0. Now at all the other points of the domain, that is minus 1 to pi, fx is differentiable and continuous. So therefore, if say a is a set of values in the interval minus 1 to pi, where f of x is discontinuous, so the set has elements, so function is discontinuous at pi and 0. So cardinality of a is L, which is equal to 2. Further, if B is a set of elements in the interval such that fx is not differentiable, so the set has elements pi, 0 and 1. Cardinality of B is m, and that is equal to 3. So therefore L plus m equals 2 plus 3, that is 5. So this is our final answer. I hope you understood it well. Best of luck and thank you.